Okay, in this tutorial we'll take a look at a cube and a cylinder, maybe measurements in inches, and or this volume in cubic inches and this volume in cubic inches. And maybe we want to make these have the same amount of cubic inches in volume so they hold, say, the same amount of gallons of water, US gallons of water. In order to do that, we need to have these dimensions come out so they are basically have equivalent volume. So let's see how we can do that, because maybe you're making a fluid simulation within Blender and you want maybe to pour the contents of a cylinder into a cube and you want it to fill up exactly. So as your animation is going on, you see all the water leaving here and then it exactly fills this here, because that might be a practical application. So this is the kind of stuff that really becomes important. So one of the things we can do, if you go onto the internet and just look up cubic inches per gallon, you'll find a definition, and in the United States it's basically 231 cubic inches per gallon. So we're saying if you take any shape object and give it a volume of 231 cubic inches, that'll have enough space within it to hold 1 gallon of water. Or liquid. So we'll deal with water for the moment. But again, remember, this assumes that we have really thin edges, because if you had a really thick edge cube, then your space inside is not going to be near as much. So that's what these calculations are based upon. In the future lessons, we'll deal with thicker edge objects. So easy trick for a cube at least is, well, just take 231 cubic inches like this. And I want to take the cube root of that. Let me see if we have a cube root. Yeah, we have a cube root number right there. 6.13579. So if I cube that, where's my cube? It takes me right back to 231. So what I'm doing is the cube root is basically a way to simplify this cube, since the length, width, and height all have the same dimension. Then you can take the cube root of that and you can get back to each individual dimension like this. So when I take the cube root of 231 cubic inches, it tells me it's 6.136. So that would be like this. Here's my cube. I'm going to make one of those cheap cubes where you just draw two squares like this and you just connect the lines like that. So it's in ortho mode, like this cube here. Alright, so basically we're saying 6.136 inches for the length and 6.136 inches for the width, and then 6.136 inches for the height. And so then, just like the regular volume measurement, for the volume of a cube, it'd be the length, width times the height. You multiply those three together, which is what I was doing here when I pressed the x cubed button, and that gave me the volume. So now I know that if you design a cube that has really thin walls and the measurements are 6.136 inches on each side, that will hold 1 gallon of water, 1 US gallon of water. Alright, and so you can kind of approximate that. If you go look at a 1 gallon jug of milk, you can kind of see where that would be a typical kind of shaped space. Alright, so that's how they were able to make things like that. So now the cylinder is a little bit of a different story. So we're going to also say that the cylinder has an area of 231 cubic inches, but since we know the area of the volume of a cylinder is pi r squared h, like this, we're left with an unknown. We either have to have a given height or a given radius before we can proceed, because with two unknowns we can't solve it this way. So let's just give let's give the cylinder a height of, okay, we'll just call it 3. It's close, like that. Alright, but now based on that, now I need to know what so pi r squared h is going to be equal to 231 cubic inches. So now we have an unknown like this, but since I just gave it a height of h, that means we can it's really the same as saying pi r squared times 3 is equal to 231 cubic inches. Whoops, that's 231 cubic inches. Like this. And then, so what I can do is I can divide out that number 3 from this side. So I'm going to divide 3 from this side, and I'll divide 3 from this side. I'm not dividing out any inch terms yet. Well, no, I am, because that's times 3 inches in height. So it's 3 inches, like this. So I divide out 3 inches, and I divide out 3 inches like this. So I have to do 231 cubic inches. 231 cubic inches divided by 3 inches is equal to, it comes out, it's an exact term, huh? How'd that work out? 77. So what that is means, well, I shouldn't do it this way. I'll just use an arrow to show you what it turns out to be. So it now comes down to pi r squared, because I just divided out the height term. Pi r squared is equal to 77 square inches. Because just since, you know, if you multiply an inch times an inch, you'd get a square inch. But if you divide out a term, in this case we had a cubic inch, and we divide out an inch, and we get a square inch. So we divided the 231 divided by 3 to get the 77, and we divided a cubic inch by an inch to get a square inch. So now pi r squared, I'll put it up here now. So now we need to divide out, we need to find out what this r term is, but now we still need to, let's divide out pi. So now in this case, let's take our pi r squared term and divide it by pi. So we're going to get rid of the pi on this side, and that's going to be equal to 77 square inches. 77 square inches, and we have to divide it this side because you have to do the same to both sides of the equation. So divide out pi, and so that's going to lead to, so I'll bring the calculator back over. So we'll do 77 divided by 3.1416 equals 24.5, we'll just call it 24.51. All right, like this. So now what we're saying, r squared is equal to 24.51 square, still square inches, because I didn't divide out any inch term. I just divided out this pi term, and pi is dimensionless, meaning, you know, it doesn't have, you don't define it in terms of feet, meters, and whatever at the beginning. It's based on the radius of that circle, right? Is how we found it. So now r squared is equal to this. Now to get r by itself, essentially meaning to find the radius of the circle or the radius of the cylinder, in order to do this I have to take the square root of both sides to get rid of that exponential term. So I'll just do it like this. I'll put my square root symbol there, and I'll put my square root symbol here, and so this ends up being r. When I take the square root of r squared, I get r, and then when I take the square root of 24.51 square inches, so it'd be 24.51. I'll take the square root of that. Oh, there it is right there. 4.95. So it's equal to, and when you take the square root of a square inch, it becomes an inch. I ended up 4.95. 4.95. All right, so 4.95 inches, like that. So now I have a radius term. So then that tells me the radius, so that means the diameter is twice the radius. So that would be 5, that would be 9.90, right? So that's really 9.90, because if you just do 4.95 times 2 equals 9.90. So that means I'm coming back into the cylinder, and the reason I did that is the cylinder, it has to have a z term of 3, and then it has to have the radius term. So so this is the diameter in x and y. So the diameter is going to be 9.9, and this is going to be 9.9. What is this one? Let's see what this is. Let's making sure. Oh yeah, because now we have to change this. This is 6.136 for all of these. 6.136, and that's 6.136, and that is 6.136 inches. So now let's go look at both of these next to each other. Let's verify that 6.136, and this is 9.9. Whoops, 9.9 and 3 inches, because that's what we gave it, a starting value of 3 inches. All right, so now let's go look at the image here. So basically what we're looking at is the volume. There's that cube, and make sure this is all the way up, and that's out of the way. That's there like that. We'll put our light over here so we can see it. All right, so basically that cylinder, see, you notice there's, let's look at it in ortho mode. 1, 5. You can see if I move this cylinder, this cube over here like this, see it doesn't occupy near as much space like that. So that cylinder and that cube would hold the same amount of liquid, all right, in US gallons, like that. All right, and so then when you do your simulation, if you had the cube and you were pouring it in there, that would fill it up exactly. Got it? All right. Well, it might be a little tricky, but practice that again, and we'll just continue on slowly but surely. And I assure you, all this becomes hyper important, because there's hardly anything I don't work with within Blender when I'm doing any type of simulation where I'm not thinking this stuff. I'm either calculating it in real time in my head as I'm going along, or I'm thinking about it, so everything is kind of working out so it works out in the end to be accurate. All right, well, that's it for now, and I'll see you in the next lesson.